First, we're going to talk about parallel and perpendicular lines. So first, you should know that parallel lines always have the same slope, and any two lines that have the same slope are parallel. Yes? Oh. Okay, so again, parallel lines always have the same slope, and any two lines with the same slope have to be parallel. So you can see it in this picture. I drew two lines. When you draw a triangle that goes over one, they both go up the same amount, m, which is the slope. So an example where we might use this fact would be to write an equation of the line that goes through the point -2, 5, and is parallel to the line y equals 3x plus 1. So we're going to use point slope form and then put it into slope intercept form. So point slope form is y minus y1 equals m times x minus x1, something we learned last class. All right, so this line that we're trying to find the equation of, it's parallel to the line y equals 3x plus 1. So what do I know about its slope? Slope has to be 3. If the line I'm looking for is parallel to this line, it has to have the same slope, and the slope of this line is 3. Because this is the slope intercept form. So I go ahead and I put in my slope is 3. And then I replace x1 and y1 with the point that's on the line, which they gave me -2, 5. So just plug in -2 for x, minus -2 becomes a plus, and this is y minus 5. So there's my point slope form. And then for slope intercept form, all I have to do is take this equation and solve it for y. Distribute my 3, add the 5 to both sides, and combine like terms. So I'm going to get y minus 5 equals 3x plus 6, and then add 5 to both sides, and I get y equals 3x plus 11. Does that make sense? Okay. Okay, another fact about slope is that two non-vertical perpendicular lines always have opposite reciprocal slopes. And two lines that have opposite reciprocal slopes will be perpendicular. So what does opposite reciprocal mean? Anybody know? Yeah. Flip it and take the opposite. Either make it, if it's positive, make it negative, and if it's negative, make it positive. So in this picture, the blue line has slope from this point to this point. We go up A and over B, right? So the slope of this blue line is A over B, rise over run. And then this pink line that I drew perpendicular to it, to get from this point, so do it in another color, to get from this point to this point, we go down B and right A. Yeah, so the slope of that line is -b over A. Flipped the fraction, made it negative. A horizontal line that has 0 slope is perpendicular to a vertical line that has undefined slope. All right, so here's an example. We want to find the slope, just the slope, not the equation, but just the slope, of any line that is perpendicular to the line whose equation is x plus 3y minus 12 equals 0. So how can we find the slope of this line? The slope of that given line, how do I find it? I could change it to slope intercept form, so I just solve it for y. So I'm going to have 3y equals -x minus 12, or plus 12, sorry. Move everything, all the non-y's to the right side, then divide both sides by 3. So I get y equals -1/3 x plus 4. That's equivalent to x plus 3y minus 12 equals 0. So a line that's perpendicular to this line will have what slope? 3. The opposite reciprocal of negative 1/3. The opposite would be make it positive, and the reciprocal, flip it over, and you get 3 over 1, which is 3. So our answer is 3. Okay, so now that you have the slope, I want you to write the equation of the line that passes through -2, -6, and is perpendicular to that line. So we now know its slope. Being perpendicular to this line means it has slope of 3, and it goes through -2, -6. So let's use point slope form. They asked us to put the equation in general form. We can do that after. We'll start with point slope form. Put in a 3 for m. And for x1, I'm going to put in a -2, and for y1, a -6. So I have minus -2. Oops, I forgot the x. X minus -2. And here I have y minus -6. So the standard, or the general form, is when you have something times x plus something times y plus something equals 0. So basically, we want everything on one side so that 0 will be on the other side. So I'm just going to collect everything on one side. So right now it's y plus 6 equals 3x plus 6. And then just move everything to the left side. So this is going to be -3x plus y. When I subtract 6 from both sides, those go away, and I get equals 0. General form. Okay, so we're going to talk about slope as a rate of change now. For linear functions, slope can be interpreted as a rate of change of the dependent variable per a unit change in the independent variable. So when you're calculating slope in applied problems, keep track of the units in the numerator and the denominator, and that will help you interpret what that number means, what the slope means. So for example, in the year 2000, the average price per gallon of gasoline was $1.93. And this is adjusted for inflation. All of these prices are adjusted for inflation already. So the increases that you see are above and beyond inflation. Does that make sense? Okay. So in 2000, the average price per gallon was $1.93. In 2011, the average price per gallon was $3.53. So assuming that the price increases linearly, we want to find an equation that models the price of gasoline as a function of the year t since 2000. And we want to interpret the slope. What does the slope tell us? Okay, so all that information in there, can you pull out 2 points that might be on my line? Crystal, what do you think? Good. Okay, so $1.93, 0 and 3.53, 11. You're super close, right? But we're measuring gasoline price as a function of year t. So which one is the independent variable? Time is the independent variable. Gas price depends on time. Gas is a function of time. So it actually, we just should swap the order of your points. So we'll do 0, 193, and 11 for the year 2011, 353. So those are my 2 points. Let's come up with the slope between these 2 points. So my slope is change in y over change in, maybe I shouldn't use y and x because in this problem it is g and t. Okay, so change in G from 193 to 353. What's that? 1.6? Yeah. And then with the change in time? 11 years. Yep. So 1.6 over 11 is 0.145, approximately, if I round it. Okay, so change in G, delta G, right? What are the units on that? Dollars, right? It's measuring the price of gas. So this is dollars, right? And then my change in T, what's the units on that? Years. So this says dollars per year, 0.145 dollars per year. So what does that mean in terms of gas prices? What does that tell you? Yeah, gas prices increase by approximately 15 cents every year, above inflation. Yeah. So this tells me that gas prices increase by approximately 14.5 cents per year. Be careful with your units. If you write 0.145, your units is dollars. If you write 14.5, your units is cents. Really common mistake. I actually have been collecting pictures of this mistake all over the place. I found it in Home Depot one time. They wrote, it was a sale on trash bags, and they said it was like a bag of 100 or a box of 100 trash bags, and it was something like, they said it was 0.1 cents per bag, right? And I know I was being a huge nerd, but I called the person over and I was like, that's not right. That is, I think you mean 10 cents per bag. So I was trying to explain, you either mean this or this, right? But they mixed them up and put the wrong units, and I was like, well, do you really want me to pay this amount? Because I'd be paying 10 times less than what you were trying to charge me. So I've seen it in Home Depot. I saw it Arizona Pizza Kitchen by the movie theater at the Cinemark. I saw them advertising giant banner on the front of the store that said that. Yeah, I know, right? That says four for $1. But that's not, they don't, no, that says 400 per dollar. Right. 25 cents per wing would be four for $1. That says it's a quarter of a cent, like cut a penny into 4 pieces. That's how much you charge for a wing. Here's a penny, keep the change, right? All right, so we've got the interpretation of the slope. I just want to finish writing my equation here that goes through these 2 points. So it's going to be y equals 0.145x plus, yes, thank you, g of t, which means that this should be a t, plus my y-intercept, which is what? 193, because what your y-intercept is the value of y when x is 0. So yeah, so they gave us that one. So that was nice. And here I used the 0.145 because my 193 was in dollars, so I want my slope to also be in dollars. So my units are consistent. Okay. Now we can talk about using slope to measure rate of change, like we did in this example for a linear function. But we can also use a slope to measure the average rate of change for any function, even if it's not a line. So if we have not a straight line, the average rate of change between 2 points is the slope of the line containing the 2 points. So that is called the secant line. And for example, this data that I got for question 3 came from this graph that I got from the US Department of Energy. And it says the green graph shows gas prices from 1929 to 2011, adjusted for inflation. And the graph clearly shows that the data is not linear, right? It goes up and down kind of randomly. We can still find the average rate of change of gas prices from 1929 to 2011. And we want to describe what it means. Okay, so it's hard to tell what this says. That price is somewhere between $2 and $2.50. So I told you it's $2.29. The same place where I found this graph, they had a big long table with all the data points in it. So that was $2.29, and in 2011, it's $3.53. Okay, so my slope is going to be change in gas prices over change in time. So 353 minus 229 over, what's my change in time, 1929 to 2011? 82 years. You just subtract them. 2011 minus 1929. And 229 to 353. 329. 124. Okay. And your units on the 124, that's in dollars, right? That is the change in price. So gas went up by $1.24. And 82 is your change in years. 82 years have passed. So now we do the division. $1.24 divided by 82, and we get 0.015 dollars per year. Cents per year, right. So if you multiply that times 100, you get 1.5 cents. Yeah, why is it way off? Larger amount of time, yeah. So it just happens that between 2000 and 2009, so if I mark these points here, 2000 is somewhere like here, and 2011 was where we went to. The slope between those 2 points is very steep, and that's where we got 15 cents per gallon per year. But if I connect 1929 to 2011, not as steep, right? So the rate of change on average is less. So I could write this as $0.015 per year or 1.5 cents per year. So I actually found this graph really interesting, that gas prices from 1929 to 2011, I mean, they went up, but not by a crazy amount. It really is surprising how we have managed to keep them relatively under control. Right? Very true. With much increased supply and much increased demand and decreasing supply. Yeah. Very true. I was just going to ask, do you guys know how much gas costs like in Europe? Yeah, it's like $8 a gallon or something. Yeah, $10 a gallon, something. Yeah, so this might be artificial. Yeah, our government does subsidize gas prices to keep them low. Okay, so you can calculate the average rate of change for any function by doing change in y over change in x. Just like you calculate slope, it's the slope of a secant line connecting the 2 points. So this is like, you know, a vanilla kind of question. There's no context or anything. I want you to find the average rate of change for the function x cubed from x1 equals 1 to x2 equals 3. So don't get confused by this notation, right? F of x2 and f of x1, you should just read those as y2 and y1, right? Remember, f of x is just a fancy form of writing y. Okay, so this just says y2 minus y1 over x2 minus x1, which is just the slope of the line through those 2 points. Okay, so what are my 2 points here? If I'm working with the function f of x equals x cubed, from x equals 1 to x equals 3, what are my 2 points that I'm finding the slope through? Sure, I could write it like that. 1 comma f of 1 and 3 comma f of 3. Right? So they gave me the x values, so I can put those in as my points. But then I have to calculate the y values by plugging into the function. Make sense? Okay. So if I plug a 1 into x cubed, I get 1. And if I plug a 3 into x cubed, what do I get? 27. So these are the 2 points I'm trying to find the slope between. Average rate of change for the function x cubed from x equals 1 to x equals 3. That means just find the 2 points on the graph that have an x coordinate of 1 and an x coordinate of 3 and find the slope between them. So my slope here would be change in y over change in x, which is 27 minus 1 over 3 minus 1, which is 13. And there's no units on that because this problem doesn't represent anything. So just 13. Make sense? So this kind's boring. It's the exact same thing we just did with the gas prices, right? It's just that this made more sense because it was in context. So we do the context one first, and then you say, okay, I could do the same thing for any function f of x. Change in y over change in x. All right, so now there's some problems for you to work on in your groups, and I will come around and help as needed. Okay, so we want to write an equation of the line that goes through -8, -10, and is parallel to the line y equals -4x plus 3. So I'm going to start with point slope. It's kind of the easiest one. And I'm going to plug in stuff that I know. Now this line, whose equation I'm trying to write, is parallel to -4x plus 3, so what's its slope? -4. So I put in a -4. Okay, and then I just plug in for x1, -8. So instead of writing minus a negative, I'm going to change that to a plus. And same thing over here. For y1, I'm going to put in -10, which becomes plus 10. So there's my point slope form. And then to change it to slope intercept form, I just solve for y. Get everything on the right and combine like terms. So I'm going to have y equals -4x. And then -4 times +8 is -32. And I'm going to subtract 10 from both sides, so I get -42. It's good? Everybody have that? Okay. So if I want to write an equation for a line that goes through 4, -7, and is perpendicular to x minus 2y minus 3 equals 0, I'm going to start with point slope form. Yeah, I should probably turn my other equation, x minus 2y minus 3 equals 0, into slope-intercept form. Why do I want to do that? Because I need the slope. I need to know the slope of this line. The easiest way to figure out the slope of this line is to solve for y. So let's see, this is going to end up being negative 2y equals negative x minus 3, divide by negative 2. So I get y equals 1/2 x plus 3/2. What's minus? Oh, the plus 3. Yeah, I moved the 3 over. Thank you. Minus 3/2. Okay, so the slope of the line that my line is perpendicular to is 1/2. Then what's the slope of my line? Negative 2. Opposite, make it negative. Reciprocal, flip it over. So this is going to be negative 2 x minus x1. Now I use my point and I plug in a 4. And y minus y1, so I get plus 7. So there's my point slope form. And then they also asked for the general form, which means that one side has to be 0. Okay, so my general form, I'm going to have y plus 7 equals negative 2x plus 8. And I'll just move everything to the left. So I get 2x plus y, subtract 8 from both sides, and I get minus 1 equals 0. Okay, so for number 3, in 1994, 617 active duty service members were discharged under Don't Ask, Don't Tell. In 1998, 1,163 were discharged under the policy. I want to use the ordered pairs 1994, 617 people, and 1998, 1,163 people to find the slope of the line through the 2 points. Okay, so my slope, remember, is just change in y over change in x. So I'm going to do 1163 minus 617 over 1998 minus 1994. All right, 1163 minus 617 is 546. And what are the units on that 546? People. Okay. And then 1998 minus 1994 is 4. And what are my units on that? Years. Okay, so I divide 546 divided by 4, and that gives me 136.5 people per year. So what does that tell you about this situation? Yeah, Tony. Oh, yeah, sorry. Yeah, it says to the nearest whole number. So I'll do this as 137. Yeah, that makes sense. All right, so what does that say in the context of this situation? Yeah, yep. So every year, 137 active duty service members were discharged each year under the Don't Ask, Don't Tell policy. Now, when I calculate this, this is on average, right? This is 137 on average each year. It might have been 136 one year and 138 the next year. And yeah, it could be high one year and less the next year. So I should note this is on average. Okay, so average rate of change for a function from x1 to x2, and I've given you x1 and x2 values. So for f of x equals 3x, average rate of change is just the slope of a line, right? So I need 2 points to find the slope of the line. So I've been given x values. How do I get y values? Plug them into the function. Yeah. So I'm going to have 0, comma 0. When I plug a 0 into 3x, I get 0. And 5, comma 15. And then what's my slope? 3. Oh, that's also the slope of the line, right? F of x equals 3x has slope 3. Do you think that that is a coincidence? Did I just happen to get a slope of 3? Right. The slope of the line is always 3. So remember, the average rate of change is the slope of the line connecting 2 points on the curve. So my 2 points were here and here, right? The slope of the line connecting them is going to be the slope of the whole line. Same as the slope of the whole line. So that's not true for a nonlinear function. So if I look at b, x squared plus 2x, and I want the average rate of change from 3 to 5. So let's take a quick look at the graph of x squared plus 2x. X squared plus 2x. Actually, I don't think that's a good window. Hold on. I need to be able to see the point on the graph when x is 2. So I can see that one, but I also need to be able to see when x is 5, and that's way up here. So I'm going to change my window a little bit. Let's do like negative, oops, -3 to 7. And then this doesn't need to go so low, but it needs to be much bigger. Maybe 35. Okay, so average rate of change of a function means connect 2 points on the function with a secant line and find the slope between them. So x squared plus 2x is graphed here. I want the average rate of change from x equals 3 to x equals 5. So here at 3, I put a point, and at 5, I put another point, and I want to find the slope of the line that goes through those 2 points. That's called a secant line. So the way I get the coordinates of the points is this one is x coordinate of 3 that was given. I get the y coordinate by plugging into f of x. So 3 squared is 9 plus 6 is 15. And then this one, my x coordinate is 5. And when I plug 5 into x squared plus 2x, I get 35. Oh. Okay, so now I just find the slope between those 2 points. 35 minus 15 over 5 minus 3 is 20 over 2, which is 10. And then for square root x, I can get my 2 points by plugging each of the x's in. So I have 4 comma what? 2, and 9, comma 3. Just square rooting the x value to get the y value. And then my slope, my average rate of change, will be 3 minus 2 over 9 minus 4, or 1/5. Any questions? What? I know, I am. Well, you know what? You know why? You know why? Is because